I hope everyone is very good, very fine. So we are again back with the rapid revision session for the next topic, that is redox reaction. Chalo. What is redox reaction? Let's first talk about that. So I will not waste a single seconds, and now we are there on the redox reaction. And here, what we can see that redox reaction are those reaction where the name itself suggests to break that. Red is not for red color. Basically, it is for red reduction, and OX is for oxidation. So reduction and oxidation. So there is a reaction where simultaneously reduction and oxidation is taking place. What is reduction and oxidation? The question should come, though I know that because it's a revision session. So I am dealing with those students or those people who already know these things, right? So there are few of the different ways of finding out or when the oxidation is going on, where the reduction is going on. So there were different ways, or you can say these things are given as the definition. So loss of electron, if the electron is lost, so just think about it, electron is negatively charged. If the negative is lost, something becomes positive or something becomes less negative. So if something becomes less negative or more positive, so it is called the increment in the oxidation number. The loss of electron or increment in the oxidation number, it is known as oxidation. Just think opposite, gaining of electron. If something gains electron being negative, that substance will become more negative or less positive. If something becomes less positive or more negative, so there oxidation state is decreasing. If something oxidation state is decreasing, what we can say? We can directly say here the reduction is taking place. So these two things are the best way to understand what is oxidation or what is reduction. So I would say loss of electron is oxidation, gain of electron is reduction. Loss of electron translate to increase in oxidation state, and here gain of electron translates to decrease in oxidation state. These two things, if you remember, that will be enough, because others have many exceptions like addition of O2. Of course, addition of O2 in most of the cases is oxidation. Like if you just take sodium plus oxygen converting, consider into NaO. So what we can say, Na was here 0 oxidation number, here it is +1. So going from 0 to +1, so oxidation number is increasing. For sure here the oxidation means addition of oxygen is nothing but it is like oxidation. But what about fluorine? If fluorine adds with oxygen, it converts into OF2 or O2F2, whatever it is. So here oxygen is what? +2, fluorine is -1. So here fluorine was 0 and going from 0 to minus, you can say a general thing to say no, addition of O2 is not at all a generalized thing that you can go with. So I would not suggest you to go with these two things, that removal of hydrogen and addition of hydrogen. No, please do not. With the addition of hydrogen, like there is another that addition of hydrogen generally is reduction. But is it always? No, it is not at all. Generally, because I can say you one of the example like sodium. Sodium when reacts with hydrogen, it will convert into NaH, that is sodium hydride. Sodium hydride, here sodium was 0, here sodium is +1. So it is going from 0 to +1. So it is oxidation, but here we are reading in reduction. So no, for not for sure. So please, this addition of oxygen or removal of hydrogen, or addition of hydrogen or removal of oxygen, these two cannot be generalized. Always remember. Next, addition of electronegative element, for sure it is correct. Removal of electronegative element is reduction. Keep in mind, that's it, right? Not a big deal. Next, oxidizing agent and reducing agent. Always remember. Let's say oxidizing agent is also known as oxidizer. What we can say? Oxidizer, or it is also known as oxidant. And what about reducing agent? It is also known as reducer or reductant. Always remember that I am a teacher, right? Teacher teaches to whom? Teacher teaches others, then I am called teacher, right? So a reducer or oxidizer will be called oxidizer. Why? Because it oxidizes others. That's a simple thing, right? Similarly, reducer is reducer because it reduces others. That's it. I hope you understand it. So oxidizing agent oxidizes others, so reduces itself, while reducing agent reduces others while oxidizing itself. That's it. So note, oxidizing agent and reducing agent is applicable on whole compound, though I will show you how it is all working. Redox reaction in terms of electronic concepts. I see Oxidation reduction is nothing but it is loss of electron. So loss of electron, I can show you few of the example. Like let's say sodium is there, sodium converting into Na plus by losing one electron. And what about that? Let's say there is O minus 2 converting into O2 2 minus converting into and giving 2 electrons. What we can say that here it is losing 2 electron, it is also losing 2 electrons. So these will be nothing but this is something that we can say that. What is that? Or take one more example. Cl minus converting into Cl, or you can say Cl atom only, no issues, or whatever it is. Half of Cl2 plus electron plus electron. Okay. So here what we can say that this is something that loss of electron is nothing but loss of electron is oxidation. What about this gain of electron? Gain of electron is what? Reduction. How do you see gain of electron? Consider chlorine is there, by taking electron converts into F minus. So of course it is 0 going to -1. So oxidation state decrease. So therefore it is reduction. That's all. What about that? Can you see that Cu plus 2 by taking 2 electrons converting into copper solid? Can you see it is plus 2 going to 0? If plus 2 to 0, oxidation state decreases. So therefore it is oxidation or reduction? For sure it is reduction. Not a big deal, easy, right? Next. Now we have come to the next point, that is in each of the following reactions indicate the species oxidized, the species reduce, the oxidizing agent and the reducing agent. अच्छा ये आपको बताना है. Okay, चलो let's find out. Always remember something that species oxidized. Species oxidized means if something gets oxidized, so it reduces others. So species oxidized matlab it is reducing agent. The species reduced, so if something gets reduced, so it is acting as the oxidizing agent, and oxidizing agent and reducing agent. Actually, it is only the same thing. Na2H2O3 plus I2 converting to NaI plus this. I'm directly telling you some of the things that do not ever see sodium or fluorine, these things in any of the reaction, or generally oxygen also, because they do not change their oxidation state. Generally, I'm not telling always. Here, talk about sodium. Leave the sodium. Directly talk about sulfur. Here, Na2H2O3. It is plus 2. Here it is minus 6. Here it is minus 6 plus 2 minus 4. It is what? Plus 2. Going to Na2H4O6 minus 12. Here plus 2. How much it is? Plus 2.5. So going from sulfur is going from plus 2 to plus 2.5. So sulfur is getting oxidized. Nothing. No change in oxygen. No change in oxygen or sodium. What is that? Only sulfur is changing its oxidation state. That is plus 2 to plus 2.5. So what we can say? Here it is getting oxidized, so it is what? Reducing agent, because it is getting oxidized. What about this I2? I2 is 0 converting into I minus, iodide. So 0 to -1 means it is getting reduced. So it is what? It is oxidizing agent. Simple. FeCl3 plus H2S converting into FeCl. Chloride also here. You do not have to see that. Fe plus 3. Here it is Fe plus 2. Though you can just check all the oxidation numbers. See. These things, I hope everyone you know that how to find out oxidation number, right? Here Cl, do not see that sulfur. Here -2 converting into sulfur 0. Sulfur going from -2 to 0 means it is getting oxidized. If something gets oxidized, it will be acting as the, yes, of course, it is getting oxidized. So therefore it is acting as the reducing agent. While it is getting reduced, so therefore it is oxidizing agent. So I hope here you can see I'm doing it faster. 0 plus 2, 0 minus 3. So therefore nitrogen getting reduced. So this is oxidizing agent. While it is magnesium 0 to plus 2. So therefore it is reducing agent. Na2O2 plus this. Here, what about this? Can you see that sodium does not change? What about here oxygen? Oxygen is here -1. Here oxygen is what? -1. And going to what? Na2O, that is -2. From -1 to -2 means what is the change? It is getting reduced. So therefore it is acting as the oxidizing agent. What about here chromium? Chromium ke oxygen, it is not changing its oxidation state because it is -2. Here it was +6 and Na2 Cr2O3 +3 and converting into +6. So it is getting oxidized. So of course if it is getting oxidized, what we can say? It is reducing agent. Always remember, if you have found out oxidizing agent, the another will be reducing agent. If you have found out reducing agent, the another will be oxidizing agent. That's a simple thing, because we know that in a redox reaction, not only oxidation will take place, not only reduction will take place. Both of them will be taking place simultaneously. So if one thing is oxidizing agent, another has to be reducing agent, yeah, without any doubt. Next, H2O2, these things, I hope you can do it very fast. -1, 0, +1, 2, 0. So Ag +1 to 0, so therefore going reducing. It is getting reduced. If it is getting reduced, so this is what? Oxidizing agent. It is -1 to 0, getting oxidized. So this is what? Reducing agent. Without any doubt, so very easy game. Which one of the following reaction is a redox reaction? Redox reactions are those where the oxidation states of the different elements change. आइए जरा देखते हैं. CuSO4 plus NH3 converting into this. Please check it. Here copper is also +2. Here also it is +2. NH3 -3. Hydrogen +1 -3 +1. No change. Same. Nothing. Wait, no, it's not at all. Here Na2SO4 plus BaCl2 converting into Bs. It is nothing but, can you see that here all these ions are changing into it? Barium sulfate ban gaya, sodium chloride ban gaya. So therefore ion exchange. No, not at all. It is also not a redox reaction. Next, SO2 plus H2 converting H2SO3. Just think about it. Here sulfur is what? +4. Here sulfur is what? +4. Here hydrogen is +1. Hydrogen is +1. -2, -2. Oxygen is -2. Is there any change? No. Oxygen was -2. It is -2. No. So of course it is the correct answer. It would be the correct option. Can you see CuSO4? Here it is +2. Ki. Here what we can say, Cu2I2. Can you see that copper is now +1? So going from +2 to +1. So what we can say, it is getting reduced. So of course it is going to be in the right direction, right? Here I is -1 and going to 0. So here oxidation state changes. Therefore redox reaction. Not a big deal. Easy one. Next. Oxidation number. What about this oxidation number? Oxidation number is the charge. This may be real or this may be unreal. The virtual or real charge is that you see on any of the element in any of the given compound. Or so this will be what? This will be called oxidation number. Achha, just think about it. What is this? When it is virtual and when it will be real? When there is a when there is ionic substance, so there the charges is what? Real. Cations has the real charge, anions has the real charge. But what about if it is a covalent compound? So in covalent compound, we just denote that negative or positive charge from our side only on the basis of electronegativity difference. If something is more electronegative, is connected with the less electronegative element. So more electronegative element will have the pulling of the electron tendency. It will try to pull the electron. Once something pulls the electron, it will become negatively charged. So what we see? So we just give by ourselves few of the negative and positive charge. So this is not the real, but it is the virtual, right? Not a big deal. So for covalent compound, the charge present is virtual, while for ionic, it is real. Okay. Next, we are going towards practice question for rules for finding oxidation number. Few of the rules are there, though here it is not written, but I'm telling you verbally. I hope this is all you know about it. Just go through it, revise it. Everybody know that oxygen generally shows -2, but it can also show +2, +1, -1, -1/3, many more that you will see, +half, like these things, oxidation states, it can show in different you can say examples, right? Chlorine or you can say halogens. Halogens generally show -1, or you can say chlorine, bromine and iodine, they generally show -1, but they can also show +1, +3, +5, +7. These things also it can show, but fluorine always -1. Why it is so? Because fluorine is the most electronegative element in the periodic table. जो सबसे electronegative है उसको कौन positive कर सकता है? Nobody has that guts. Next, what about this? What about that? What to say? Alkaline, alkali metals. Alkali metals always +1. Alkaline earth metals, they will always be +2. So please keep these things. I think सबको पता है ना, right? So these things, everyone you know that. And next, there will be a rule that I can say that if there is something in its elemental state, or if metals are there in the just metallic state, so what they will, or in the free state, so they will have the oxidation state 0. So metals in metallic, or you can say free state, and elements in elemental state have oxidation state how much? Oxidation state always 0. I'm using this oxidation state. You can also call it oxidation number. Please note it down. So these points are there. You always have to keep in mind, right? Though there is difference between oxidation state and oxidation number, that is, if the question comes, then I will talk about that. But right now, just keep these things in mind. Next, one more rule is there here. Sum of the oxidation state of all the atoms in a given molecule equal to the charge present on it. What do I mean to say? I mean to say, let's say there is H2SO4. Let's say hydrogen has the oxidation state A, sulfur has the oxidation state B, oxygen has the oxidation state C. How many of the hydrogen is there? 2. So 2 into A plus how many of the sulfur is there? 1. So 1 into B. How many of the oxygen is there? 4. So 4 into C will be equal to what? Will be equal to 0. Now this A, B, C are nothing but these are oxidation states. I hope you understand it, right? So please keep in mind. I have just given you a simple example. This may also be ionic. So there is not an issue. Let's say there is an ionic substance. Let's say there is, what to say, NH4 plus. So in NH4 plus, can you see that oxidation state on nitrogen, consider it is X. Hydrogen has considered Y. So how much of nitrogen is there? 1. So X plus how much of the hydrogen is there? 4. Y will be equal to what? How much of the positive is there? Plus 1. X plus 4y will be equals to plus 1. Not a big deal. Very easy. Calculate the oxidation state of the marked atom. A marked atom के oxidation states find out करना है. I will not do all. Most of them will be for your homework. Few of them I will take. Not a big deal. Here oxygen always show generally -2. How many of the oxygens are there? 4. 4 oxygen will give how much? 1 oxygen -2. So 4 oxygen will give -8. If -8 is there, but overall is there only -1. So means out of -8 only -1 is being reflected. Means किसी ने उसके -8 को -7 को क्या कर लिया? खा लिया है. Someone has cancelled the -7 out of -8. That's why there is what? -1. That's why the net is how much? -1. So this plus -7 will be eaten by only +7. So manganese has +7. I hope you understand it how it is coming, right? Similarly, here you will get +6. Always remember manganese has the maximum oxidation state +7. Chromium has the maximum oxidation state +6. I'm telling you these things simultaneously. S2O3 2 minus. What is there? Can you see that here? Oxygen is there. Oxygen, how many are there? 3. 3 to the -6. But here it is how much? -2. Achha, -2 is there. I just want to solve it, by the rule. Chalo, bas aise hi man kar raha hai. Let's do it. Consider sulfur has the oxidation state X and oxygen has oxidation state, you all know that, -2. So how much of the sulfur are there? 2. So 2x plus oxygen, you all know that oxygen has how much oxidation state? Generally -2. I told you. How much of oxygen is there? 3 into -2 is given how much overall its charge is? -2. So what we can say? X will be equal to, you can solve it. It will be -6. -6 going that side plus 4 divided by 2. It will be how much? +2. So sulfur has X value how much? +2. So these are the things. I hope you can do it very easily. I will not just go to all of these things. You can just see that. Now next, directly come to this point. NiCO4. Carbonyl. Carbonyl is nothing but it is a neutral substance. Carbon monoxide is a neutral, right? So even if you take how many, doesn't matter. It is 0. So nickel will also have what? 0. H2SO4, you can easily do it. Oxygen is what? -8. Hydrogen is what? +6 +2. So -8 +2 is how much? -6. Someone is cancelling that -6. For that, how much of will be needed? +6. So sulfur has what? +6. I hope you can do it very easily. You can do by any rule. Either you can do it by like that, or you can think in your head and you can do it very easily. Not a big deal. Right? Here, what we can say? Ki3. Oxidation number it is asking, not oxidation state. Can you see? Oxidation, okay. Just if it still if it is, what I feel that it is asking for oxidation number only. Here potassium is what? +1. So here 3 iodine will have to give how much? -1, right? So how much of the iodine is there? 3. Consider it, 1 iodine has how much of oxidation number? That is X. So 3x equals to -1. So X will be equals to -1/3. This is what you can do. But in reality, how will you do it? You know that iodine is nothing but it is something like -I- is giving its electron to I2. So 1 iodine will have -1 while 2 other iodine will have neutral. You can just think like that. FeO, oxygen is what? -2. So it will be +2. Not a big deal. Fe2O3, same thing, you can do it. Not a big deal. Next, what is the difference in oxidation state of the two types of sulfur atoms present in the thiosulfate? What is thiosulfate ion? I hope everyone you know that. S2O3 2- is thiosulfate. When sulfate, when the thio is used? Whenever there is any element or substance or compound, if you remove oxygen and put sulfur or replace oxygen by sulfur, the prefix thio is used. Though doesn't matter. Just use it. and make because there are few rules. There are few rules for this charge, or you can say for oxidation state, oxidation number ke liye there are few rules. Always remember, if let's say A, if same atoms are there, so both of them will have how much oxidation number? Same. Consider there is A, B. Consider electronegativity of A is more than electronegativity of B. So what will happen? Whatever has more electronegative, it will have -1, while B will have how much? +1. Consider A double bond B. So because there are two bonds, more electronegative element will have more electronegative element will have, because electron will coming towards it, -2, while it will have +2. This is the oxidation number. I hope you understand it. A triple bond B. So I hope you can do it very easily. -3 +3. Not a big deal. So आओ ऐसे क्वेश्चन यहाँ पर देखते हैं. What about this sulfur and oxygen? Who is more electronegative? Oxygen. How many of the bonds are there? 1. How much it will be there? -1. So sulfur will get how much? +1. What about this bond? Here it is -1. What about this sulfur? +1. Okay. What about this S double bond O? There will be -2. How much of the sulfur will have? +2. Chalo. So what about this? It is kind S bond is there. So you will say that okay, S bond is that just like AA bond, right? Because these same atoms are there. So there will be no electronegativity difference. There should be no electron transfer, or you can say there should be no electron pulling. But you are wrong here. It is one of the very important examples. It is one of the very important examples. Please keep in mind, what is this? The main thing here, the main thing you have to understand here, that this sulfur has how many of the sigma bonds? 1, 2, 3, 4. If 4 bonds are there, 4 sigma bonds are there. So what we can say, it is sp3 hybridized. What about this sulfur? This sulfur, can you see that having 2 lone pairs? Yes or no? So if it is having two lone pairs, so how many of the sigma is there? 1 sigma and 2 lone pair. So this is having 1 sigma plus 2 lone pair. So what will be the hybridization? 3. The steric number is coming how much? 3. So therefore sp2 hybridized. So if sp2 hybridized is there, so here percentage S character is how much? Because out of 3 orbitals, how many of the sulfur is? So it is 1. So 33% almost. Here, while here in sp3, percentage S is how much? Percentage is 25%. We know that electronegativity is directly proportional to percentage. So this sulfur is more electronegative. It is more electronegative. If it is more electronegative, this sulfur will pull the electron. How many of the electrons? Of course, 2 bonds are there. So -2, this will have +2. So what we can say, what are the oxidation states came, or this is there? Can you see? This sulfur is having oxidation state -2, while this sulfur has got +1, +1, +2, +2, that is +6. So what it is asking for, what is the difference between the oxidation state? So 6 minus of -2 will be coming how much? 8. 8 is the answer. I hope you understand it. How did I do that, right? Next, find out the oxidation states of each element in the following compound. Okay, there are few very good examples here. We are just going to deal with. Okay, now see, CrO5. I'm just making the structures because these are very important structures. So please keep in mind after structure only. Otherwise, you will think that 5 oxygens are there. 5 oxygen means -10. So for -10, because it is neutral, you will think that chromium is what? +10. But chromium can never exceed +6 oxidation state. So always remember, whenever there is, sometimes the case is there, an element is showing more oxidation number than it can, or its maximum oxidation number, always remember that there is peroxy linkage pakka present in that. Okay, so of course we can see that due to the peroxy linkage, this oxygen is having how much? -1, -1. That you understand here. I hope you understand what it is happening. Though आप इस यहाँ से आप देख सकते हो. Here, how many of the bonds are there? It is -2. So chromium will have +2. यहाँ से -1, -1, -1, -1. So this will have +4. So +2 +4 will have how much? +6. So how much it is? It is not +10 is wrong, but correct is +6. What about H2SO5? H2SO5 is also known as carose acid. They may also give you the name. What about that? Just carose acid. What's your H2SO5? Always remember, for any of the oxy acids of sulfur, you have to write like that. First of all, write sulfur. Then think about the H. Whatever is the number of hydrogen, just connect with the OH. Okay. How many of the OH bonds are there? Because 2 hydrogens are there, so there will be 2 OH bonds are going to be there. Pakka. Next, Think about that. How many of the oxygen are still left here? 3 oxygen you still have. Sulfur can make 6 bonds. Okay, make that. One extra is removing or leaving. So what we can say, there will be something. OO bond is there. So how many of the peroxyl linkages are there? 1 peroxyl linkage. In this, if someone asks you how many of the peroxyl linkages are there, 2. Such kind of questions are asked, mere bhai. That's why I'm telling you. Okay, what we can say? So 1 peroxyl linkage. Due to that, if you just see that sulfur will have how much oxidation state? Please remember +6. S2S2O6. Just think about it. It was first. It was second. What about that? The third one. Third one, S2S2O6. Just make the 2 sulfurs. How many of the OH bonds are there? Can you see 2 hydrogens are there? So make 2 OH bonds. 2 OH bonds. Okay. Now, how many of the still oxygens are remaining to be used? 4. To give double bond O, double bond O, double bond O. There is no extra oxygens left. So there is something like that. You can just do that. That there, because it is same sulfur is there. So if same sulfur is there, there will not going to be any oxidation state due to that. What will be there? -2. -2. So it will be, and here -1. So sulfur will be here +5. Same sulfur will have +5 here. So here sulfur is what? +5. Br308. What about that? Br308 is there. So again, you can just do the same thing. What you can do? That 3 bromine and 8 oxygen is there. How can you use that? Just think about that. Bromine and bromine and oxygen. How many of the oxygens are there? 8 oxygens are there. Okay, and okay, Br double bond O, double bond O, double bond O, double bond O, Br double bond O, double bond O. How many of this is there? O. Br308. How many? 6 is completed. Okay, Br308. O double bond O. Can you see here how many of this is there? Can you see that here bromine is there? 7 bonds for sure. It is correct. So what we can say, bromine Br308. We can see that here bromine all going to be oxidation states it is asking for. Can we see that there is 6 bonds is there? So -2, -2, -2. So it will have +6 here. -2, -2. So this will have +4. What about this? -2, -2, -2. So it is what? +6. What we can say? You can just do that. Next. So here this bromine, the middle one is going to have +4, while the side one is going to be +6, +6. Not a big deal. You can do it. Br308. Next one, S2S406. Now you can just try to make the structure, and on the basis of structure you can just do the delocalization of electron, and on that basis you can think about it, right? S2S406. So okay, I'm giving you this for, you can just take it for, or not a big deal. I'm just making 5th one. At least I'm making it that you can later on do it. S double bond O, double bond O, S double bond O, double bond O, OH, OH, S, S. There is SS bond in between. Okay, so this is what? H2S4O6. H2S4O6. When you try to solve it, again you will get +5 here, and you will get +5 here. What about this? So it is also done. 5. H2S2O3. H2S2O3 already done. Yes or no? Each we have done that. This one only. Thiosulfate. So it is thiosulfuric acid. Not a big deal. H2S2O8. What is that? 7th one. S2S2O8. What is that? What is that? I hope you all know that. It is also known as Marshall's acid. Marshall's acid. So sulfur, double bond, OH, double bond, OH. Each में double bond O, single bond O. So it is what? It is peroxy linkage. It is what? Peroxy linkage. You can just check that. Again, you will get the sulfur is having here +6. Here also sulfur is having +6. You can do it. Not a big deal. So it is also done. 8th. H2S2O7. Oleum. H2S2O7. How do you do that? S double bond O, S double bond O, OH, OH, and in between there is going to be 1 oxygen, because what did I say? Always make this skeleton, make, or in between whatever is there, fit it, because 1 oxygen was remaining, so just fit it. Next, we are going to talk about it. C3O2. Which number it is? 9th number. C3O2. What is that? C3O2 is nothing but carbon suboxide. It is known as carbon suboxide. Carbon, double bond O, double bond O. Can you see this carbon, both of them from both the side is carbon carbon, so it will have oxidation number 0. It will have -2, so it will have +2. It will have -2, so it will have +2. These two carbon having +2, while this carbon is having plus, that is 0. I hope you understand very easily. Oxidation states of the Fe in Fe3O4. Always remember that Fe3O4 is FeO 1 mole plus Fe2O3 1 mole. So just add it. Fe3, oxygen 1, oxygen 3. 1 plus 3, 4. Fe3O4. Here Fe is +2. Here Fe is +3. So, okay, oxidation state. Basically, it should have been asking for oxidation number. Okay, not a big deal. It's okay. Because they use these words just interchangeably. No problem. Here in Fe3O4, oxygen is how much? -8. So Fe will be have +8/3. Option D is the correct option. Next, the correct order of nitrogen compounds in the decreasing order of the oxidation state is. Can you see that HNO3? I'm writing it down. +5. Nitrogen NO. Oxygen -2. So nitrogen is +2 because it is less electronegative. Nitrogen is here 0. NH4 Cl. So here it is -3. Can you see that? +5, +2, 0, -3. Of course, it is decreasing order. So option A is the correct option. You can do it very easily. Next, which or what is the change in the oxidation number of the carbon in the following reaction? CH4 plus Cl2 converting to CCl4. CH4, here carbon is how much? Because hydrogen is less electronegative and carbon is more electronegative. So carbon will have negative charge. How many of the negative charge? Hydrogen is 4, so +4. So this will have -4. CCl4. CCl4 means now carbon or chlorine, which is more electronegative? Carbon is electronegative 2.5, while chlorine has almost 3, more than 3, basically 3, so 3. More electronegative, so it is -4. So carbon will have +4. Going from -4 to +4, how much is change? -4 to +4. C. A compound contains atoms of the three elements A, B, C. If the oxidation number of A is +2, B is +5, and C is -2, the possible formula for the compound is, always remember, it is one of the application of oxidation state. So what does it say? If you add all the oxidation states, it should be equal to the oxidation or total charge of the compound. Can you see the total charge of all the compounds is how much? 0. So we have to just check that whether all the charges are completing to or making to 0 or not. Can you see how much of the A is there? 2. A is having how much charge? 2. 2 to the 4. How much of the B is there? B is having +5. Okay, it is 5. C is how much? C is having -2. So 3 into -2 is how much? -6. 5 minus 6 is how much? -1. And how many of the BC3 part is there? 2. So it is how much? -2. So +4 -2 overall comes out to be +2. It is not equal to 0. So it is not the correct one. Wherever it makes completely into 0, that will be the correct option. A3. So therefore A3. One A is having how much oxidation number? Oxidation state +2. 3 will have +6. B is having minus how much? -5. C is having sorry, +5, right? C is having -2. -2 into 4, -8. So 5 minus 8 is how much? -3. -3, how much of this part is there? Into 2. It is how much? -6. So -6 plus 6, it is becoming 0. For sure the option will be B. You can check all of them. The aggregate will never be equal to 0. So that's why all of the other options are not correct. The oxidation number of the phosphorus in pyrophosphoric acid. Always remember when this word pyro is used. The pyro is used if you just take 2 oxy acid, 2 moles of oxy acid, and just remove 1 water from it. It will be oxy acids. It will be called pyro. Pyro will be used as the prefix, and whatever is acid, it will be used. Just think about it. H3PO4. How many moles? 2 moles. Minus of 1 moles of water. H3PO4 means H6. H6 minus 2 hydrogen. H4. How many of the phosphorus are there? 2 phosphorus. H4P2. How much of oxygen is there? 8. 8 minus 1 is how much? 7. So therefore H4P2O7 is what? Pyrophosphoric acid. Just make that. Can you just do that? Try to do that by directly. Here, it is asking for phosphorus. Can you see how much of the oxygen is there? 7. Just a minute. Yes. Okay. Can you see that here we have oxygen 7. So therefore it is -14. Here it is +4. +4 minus. So what we can say? Overall, it is how much coming? -14 plus 4. Still it is remaining -10. Who is removing that -4? -10? That 2 phosphorus. So 1 phosphorus will have +5. So answer will be what? +5. Okay. Not a big deal. Easy to do, right? Next. the oxide which cannot act as reducing agent, which cannot act as oxidizing agent. Always remember, as a rule, it is as a rule that a compound where an element is in its lowest oxidation state can act only as reducing agent, never as oxidizing agent. Just think about it. If maximum oxidation state of element in compound is there, so therefore acts only as oxidizing agent, never as reducing agent. Understanding it? So acts only as oxidizing agent, never as reducing agent. Okay, got that. Next, let's come to this point. So it is telling that cannot act as reducing agent. If something cannot act as reducing agent, means it is going to only act as oxidizing agent. Why am I saying it? An oxidizing agent gets reduced, and a reducing agent always gets oxidized. Just think about it. If something is already in the minimum oxidation state, understanding it, can it go more than lesser than that? No, it can only go up. Means it can only get oxidized, and something that gets oxidized is called reducing agent. But what about if something is already in maximum oxidation state? It cannot exceed it. So it has only option to come down, means to decrease the oxidation state. And if something decreases its oxidation state, it gets reduced. And if something gets reduced, it is called oxidizing agent. Understanding it? So if something has maximum oxidation state, it will only act as the oxidizing agent. If something has minimum oxidation state, it will only act as the reducing agent. As a rule, we have made that, right? Chalo. So here, can we see here carbon is having how much? +4. So it will act only as the, because carbon has the maximum oxidation state how much? +4. So for sure, carbon only can act as oxidizing agent. So never as the reducing agent. Understanding it? That's it. ClO2. Chlorine is +4. But chlorine can go up to +7. Chlorine can go minimum up to -2 also. So it has both the options. So many questions comes like that. Which of the following can show disproportionation? Always remember, if maximum or minimum oxidation state is there, no disproportionation. But if something has mediocre or intermediate oxidation state, it can go up, it can come down also. Such kind of reaction where an element can go or can get oxidized as well as reduced, it is called disproportionation reaction. That's it. So therefore, what we can say, that of course it can show disproportionation reaction, though the reaction is not, the question is not for that. I have just gave you extra point here. Please keep in mind, question aate hain, khub aate hain. Okay, so I hope you understand it. Here nitrogen is +4, it can go up to +5 as well as -3. Sulfur is here +4, it can go up to +6 as well as -2. So it has all the options to go down, go up. So that's why it is not the correct option. Only correct option is A. It was very important question. We have seen all the different types of forms of the question. The oxidation state of the iron in coordination sphere, Prussian blue. What is this? Prussian blue. Can you see that here cyanide is how much? Can you see? Cn is how much? +6. It's not a big deal. Just think about it. So 6 cyanide, 1 cyanide is how much? -1. 6 cyanide will have how much? -6. Consider iron has how much? X. So X -6. How much of the total is there? 3. It should be equal to how much? Consider it is Fe4. Though anyways, what we can say here, that because whatever is the positive, the same should be, whatever is the, consider +x, it should be -x. So whatever is the negative here, the same should be positive here. Consider it is. So if this is going to be, how much multiplied by 3 will be equal to how much multiplied by 4? Can we say that if it was -4, so -4 into 3 will give -12. And if it was +3 multiplied by 4 will give +12. Yes, it is going correct. But for making it -4, how much of the iron should have oxidation state? +2. Why? Because cyanide is -6. -6 + 2 gives -4. Of course, we can say that the iron in the coordination sphere means this iron has the oxidation state +2. Not a big deal. Easy, right? Next, types of redox reaction: combination reaction, decomposition, metal displacement, non-metal displacement, disproportion, comproportionation. We'll see the examples. Combination: after combining, if something changes its oxidation state, it will be combination, like 0 to +4, 0 to -2. Not a big deal. Redox reaction of combination type. Decomposition like ClO3, KClO3, potassium chloride converting into KCl plus O2. Here oxygen is -2, converting into 0. Here Cl is how much? Plus 5. Here it is going to -1, right? Changing the oxidation state. Here calcium carbonate into calcium oxide plus CO2. What we can see here, that here oxygen and carbon. Can you see that? It is non-redox. It is non-redox. Do not even think about that. Leave it. Metal displacement reaction. In a metal displacement where one metal displaces other but changing its oxidation state. Can you see it is 0? Here zinc is +2. Here +2 going to 0. So of course change in oxidation state is there. So what we can say? We can say that here oxidation metal displacement kind of redox reaction. Non-metal displacement where a non-metal displaces other non-metal but change with the change in oxidation state. Here it is 0, here it is -1, here it is -1, here it is 0. Can you see there is change in oxidation state as well as chlorine has displaced oxygen, iodine to convert into KCl. Not a big deal. You see it from, I hope you know about something electrochemical series. Yes or no? We'll talk about that just in this session only. Disproportionation reaction, the reaction in which one atom is going to be oxidized as well as reduced in the same from the same molecule. Can you see that? P4 plus NaOH converting into PH3 plus NaH2PO2. So in such case, can you see that it is 0 converting into PH3, that is -3. Here what is that? NaH2PO2. So if you just do that, so how much of the positive is there? +3, -4, +1. So 0 is going to -3 as well as +1. So 0 to reduction as well as oxidation. So here what we can say? It is disproportionation reaction because phosphorus is getting oxidized as well as reduced. Okay. You understand it. Now X2 plus NaOH, if it is cold and dilute solution, it will be converting into X, that is 0, converting into -1, and it is +1. But what if it is in the cold and dilute? But what if we take X2 plus NaOH, that is hot and concentrated? In such case it converts into NaX plus NaXO3. So what happens here? Converting into 0 to -1 and +5. So 0 to -1 it is reduction and it is what? Oxidation. Here 0 to -1 reduction, here it is oxidation. You understand it very well. I hope you understand it very well, right? Comproportionation reaction. Disproportionation ka ulta, comproportionation reaction. If there is a reaction where there are two different oxidation state in two different molecules and the same element converts into the same oxidation number. What did I say? Chalo, see the example. Why to say anything? Just see the example. Whatever. If there is any reduction, this disproportionation, uska ulta kar do. You will get that. Like X minus, then XO3 minus, converting into X2. So what we can say? Here X is what? -1. Here X is what? Halogen is -1. Here halogen what? +5. Converting into 0. So +5 getting reduced, -1 to 0 getting oxidized. Here reduction, here oxidation, but it is going to a single oxidation state. There what was happening? Single was converting into two different. Here two different converting into single. I hope it's very easy, very clear. Next, an aqueous solution of sulfur dioxide reacts with H2S to precipitate sulfur. Here SO2 acts as. What is the reaction? SO2 sulfur dioxide when reacts with H2S converting into sulfur. What we can say here? Sulfur is +4. Here sulfur is -2 converting into 0. What kind of reaction it is? Can you see that? It is the comproportionation reaction. Yes or no? +4 to 0 reduction, -2 to 0 again oxidation. Okay, that's not the point. The point is here H2S, what it is asking for? SO2 acts as. SO2. Can you see that it is getting reduced? It is gets reduced. If something gets reduced, act as oxidizing agent. Not a big deal. I hope you all understand it very well. Next, practice question for the balancing redox reaction. Balancing of redox reaction takes a lot of time. That's why I didn't come with the theory. I will directly solve the question. Though, let me tell you, always go with the, you can say, with the options also you can do it, right? With the options, put the values and get that which of the following is correct. So not a big deal. Even if you do not know the rules, you can just solve such kind of question if you have brains. Next, MnO4 -1 and oxalate converting into this. Okay, not a big deal. What do you have to do? Just see that. Here manganese is what? +7. Going to what? +2. Here carbon is what? Here +3. Converting into what? +4. Do not ever think about the oxygen and hydrogen. Do not think about the oxygen and hydrogen always. I'm telling you. Write it down. MnO4- C2O4 2 minus, converting into CO2 plus Mn plus 2. I'm telling you, very easy. Plus 7. Can you see that? First of all, see that which is changing its oxidation state? Manganese and carbon. Manganese and carbon. So first of all, you have to do the whoever is changing its oxidation state. First of all, balance them. Manganese is how much? 1. How much? 1. Do not cheat. Touch it. Carbon is how much? 2. How much is there? 1. So make it 2. Now just make few changes. Here, change is how much? Find out the change in electron or electron exchange, number of electron exchange. How much is there? 1 manganese is changing how much? 5, 7 to 2. So 1, 5. And how many of the manganese is there? 1. So it is how much? Electron exchange is. Electron exchange is how much? 5. Here talk about carbon. Carbon is how much? Plus 3 to plus 4. Plus 3 to plus 4 means change is how much? 1. And how many carbons are there? 2. 1 to the how much? 2. Always remember. So that's something that you can do it. So it is what? Electron exchange in carbon. Whatever is the electron exchange, you just cross multiply it. What you have to do? Cross multiply it. So this 5 has to be multiplied with the, because it is changing in manganese. So multiply with carbon. And this 2 multiplies because it is the changing in carbon. So multiply with manganese. It is something that, these are the few rules that we have to follow, right? Or so what it becomes? 2 MnO4 minus plus 5 C2O4 minus 2, converting into 10 CO2 plus 2 Mn plus 2. Okay, this is something that we have got. At last you have to do balancing of oxygen and hydrogen whenever there is acidic medium, because we can see that this is acidic medium. So in the acidic medium, just now think about the oxygen. How many of oxygen is there? 2 4s are 8, 5 4s are 20, 20 plus 8, 28. How much is there? 10 to the 20, 20. So how much of the extra oxygen is needed? For extra oxygen, add the water. 8 oxygen is more needed. So how much of water you will add? 8 H2O. For 8 H2O, how much of the HN is needed? Because there are 16 hydrogen extra, so there add 16 H plus. I hope you can see it very easily that what are the things it is asking for. It is asking for permanganate. Permanganate is how much? 2 permanganate. This or this. How much of the what oxalate? Oxalate, how much we need? We have 5. Okay, 5. 2 5. It is going well. And then HN. How much of the HN is there? 16. 16. Option B is the correct option. I think you can do it very easily. Not a big deal. Next, the pairs of compound that can exist together. Always remember, when there are two you can say reacting things are there, can they stay together without reacting? No. So can they exist together? No. If let's say there is acid, they will not care about it. Acid से क्या मतलब? Base का base से क्या मतलब? They will not talk to each other because they have no reaction to take place, right? But if there is acid and base, they will react with each other to give the salt and water, right? So acid and base can never exist together. Similarly, an oxidizing agent, reducing agent can never stay together. So wherever there is one thing oxidizing agent, one reducing agent, so they will react with each other to give a redox reaction. Similarly here, think about it. Here Fe is plus 3, Sn is plus 2. So it is in the minimum oxidation state. Minimum oxidation state. It is in the maximum oxidation state. If it is in the maximum oxidation state, so what we can say, this will be acting as the oxidizing agent and it will be acting as the reducing agent. What it is asking with a pair of compound that can exist together. No, oxidizing agent, reducing agent, it will react with each other to give redox reaction. Redox reaction. So can't exist together. Next, HgCl2 plus 2, SnCl2 plus 2. It is maximum oxidation because Hg shows either plus 1 or plus 2. Here it is mercuric form. So it is acting as oxidizing agent. It is acting as reducing agent. So it will also be not existing together. FeCl2 plus 2, SnCl2 plus 2. It is also minimum oxidation state. So this will be acting as the reducing agent. It is also minimum oxidation state. So it will also act as the reducing agent. So reducing agent and reducing agent has no relation or no reaction to take place. क्या बात समझ में आ रही है? Is this clear? Next, when Cl2 gas reacts with hot and concentrated H2SO4, this sodium hydroxide, the oxidation number of chlorine changes from. I hope we have seen that there what happened? Chlorine converted into Cl minus and ClO3 minus. I have shown you there in this proportionation reaction example. Can you see 0 to minus 1 and here it is plus 5. 0 to minus 1 and plus 5. 0 to minus 1 and plus 5. Option B is the correct option. Next, I hope it is very easy to write. Understand? Now we are going to talk about the N factor. n factor of the ions. What are n factors? N factor is nothing but the equivalency factor, or you can say valency factor, right? For any of the charge, whatever is the charge on that, any charge, either it is cation, any of the cation or anion, whatever will be the charge, that will be the n factor. Like sodium ion 1, sulfate 2, phosphate 3. I hope it is very easy to understand. Next, salts. For n factor, what is n factor? For any salt, consider I am taking any, let's say Al2SO4 taken thrice. Just think about it. What you have to do? You have to just do that whatever, either take cation or take anion. Do not take both. Either take cation or take anion. What is given? Charge on any one of the cation or anion multiplied by number of that ion. Okay. What does it mean by aluminium? Consider I am taking cation. Aluminium has how much of the charge? Plus 3. How many of the aluminium is there? 2. So how much is the n factor? N factor will be equal to 2 into 3. That is how much? 6. So therefore, what we can say, because we know that equivalent mass equals to molar mass, equivalent mass equals to molar mass divided by n factor. So whatever is the molar mass, you can divide by 6, and you can get the equivalent mass. Not a big deal. Easy, right? So similarly, some few examples. I will also take a double salt few examples. K2SO4 dot Al2SO4 taken thrice dot 24H2O. Such kind of questions are asked here, that what is the n factor for that? Can you see that potassium is how much? Plus 1. So 2 into plus 1 will be giving how much? 2. Al2, it is what? 3. 3 2 is how much? 6. So is there any other cation is there? No. So 6 plus 2. So just add this 6 plus, or you say n1 plus n2. That is 6 plus 2. That is how much? N factor comes out to be 8. Always remember, such kind of question can be done like that. More salt, you can see that FeSO4 plus ammonium sulfate. How many of Fe is there? 1. So 1 Fe has how much charge? Plus 2. Ammonium has how much? How much of the ammonium ion is there? 2. 1 ammonium has how much charge? Plus 1. So 2 ones are 2. 2 plus 2 how much? 4. So n factor for more salt will be 4. Such kind of double salt can also be taken care of with that, right? Acid and base. For acid and base, for any acid, whatever the number of H ion it gives, or whatever the number of H ion it gives, that will be the basicity or n factor of that acid. Or for bases, whatever the number of OH ion it gives, that will be the acidity or n factor for that base. Next, what is the equivalent mass of calcium phosphate? Not a big deal. I hope you understand it. Either take cation or take anion. I will take cation. How much of the charge on calcium? 2. 2 into 3, how much? 6. It is the n factor. So what it is asking for? Equivalent mass. Equivalent mass equals to molar mass by n factor. What is the n factor here? 6. So m by 6 is the correct option. That is D. With what is the sum of n factor of H3PO4, H3PO3 and H3PO2? Always remember, because whatever the number of hydrogen it can give 3H plus, it can give 2H plus, it can give 1H plus. So how much is n factor? N factor comes out to be 1. For it 2. For it 3. 3 plus 2 plus 1 is going to be 6. How it is coming? Always remember, only those hydrogen are ionized which are directly attached with the oxygen. So here you need to make the structure. Without structure you cannot do it. Like if H3PO4 is there, always remember POH OH OH. It is H3PO4. While if you talk about H3PO3, it is this. While if you talk about H3PO2, it is this. Can you see that how many of the OH bond is there? You can see 1, 2, 3. Here n factor is what? 3. Here how many OH bonds are there? 2. So here n factor is how much? 2. How many of the OH bond is there? 1. So there n factor is what? 1. I hope you understand it, how it is coming. So option is the 6. Next, what is the equivalent weight of the H3PO4 in the given reaction? Can you see H3PO4 converting into this? How much of the, do not do it directly. Whenever there is a reaction given, always see that how many of the H ion is taken or how many of the H ion is given. Can you see H3PO4? How many of the hydrogens were there? 3. But later on you can see that only 1 hydrogen is there. So means how many of the hydrogen it has given in the reaction? 2. Because 3 were there initially. Right now 1 hydrogen is there. So means how many of the H ion it has? So you can just write H3PO4 converting into, do not leave this Na plus. It will be looking something like HPO4 minus 2. How many of the H ion? So 2H plus. If 2H plus is given, so therefore n factor comes out to be 2. Always remember 3 were there, now it is 1. So how much is the difference? 2 hydrogen. So therefore n factor is 2. If n factor is 2, E will be equal to m by 2. Option B. Next, what is the n factor of salt in the given reaction? This is this. Okay, not a big deal. Next, you can see that here NaH2PO4. So here how many hydrogens were there? 2. How many hydrogens is there? 1. How much is the change? 1. So therefore, what is the n factor? I hope you understand it. 1 hydrogen change. 1 hydrogen change. So therefore, n factor is what? 1. Next. Now topic KMnO4 as the oxidizing agent. Always remember KMnO4 in acidic, basic or neutral medium. It shows different kind of oxidizing properties. Please remember. And its n factor also is different. Means that a different number of electron exchange takes place. Now MnO4, that is nothing but permanganate. Permanganate in acidic medium converts into Mn plus 2. So therefore, how much is the change? Initially it was having plus 7. Now going to plus 2. How much is the change? Plus 7 to 2. Change is how much? 5. So therefore, n factor how much? 5. Correct. Next, in the neutral medium, it converts into MnO2. MnO2 is what? Mn is plus 4. So change is how much? Plus 7 to plus 4 means change is how much? 3. So n factor comes out to be 3. It is very easy to understand. I hope here n factor will be 3. So here E will be equal to what? M by 5. Here E will be equal to what? M by 3. And here E will be equal to what? Because it is plus 7 going to MnO4 minus 2. That is manganate. Permagnetic converting into manganate. So here converting into plus 7 to plus 6. So therefore change is how much? 1. N factor 1. So E will be equal to M by 1. Not a big deal. I see you can understand it very easily. Yes or no? Always remember how to find out n factor in oxidation. Let's say there is any redox reaction. There are few rules are made. So whatever is the change in the oxidation number, multiply with the number of atoms that is taking care. Like I will show it. Here, so I have shown you that change was how much? 5. And how much of the Mn was there? 1. So 5 ones are 5. Similarly, here also change was 3 multiplied by how many of the manganese were there? 1. 3 ones are 3. How much is the change? 1. How much of the manganese is there? 1. So 1 into 1 is how much? 1. That's how you can find out easily n factor. N factor as it is giving you, not a big deal. We can see that in better way. K2Cr27 converting into Cr plus 3. Now always remember that potassium dichromate or dichromate always it will it will show the oxidizing character in acidic medium, not in the basic medium. Always remember, in acidic medium, never in the basic or neutral. What I'm saying? Acidic medium. Chromium is how much? Plus 6. Converting it to what? Plus 3. So change is how much? Just tell me. Change is, n factor will be here how much? Change is 6 minus 3. 6 minus 3 is how much? 3. Change is how much? 3. How many of the chromium are there? 2. So how many chromiums are there? 2. So 3 2s are 6. So that is the n factor. So here E will be equal to what? M by 6. Not a big deal. I hope you can understand it. Always remember that in basic medium does not act as oxidizing agent. Why? Because Cr2O7 2 minus converts into CrO4 2 minus in the basic medium. So here it is plus 6 converting into plus 6. Is there any redox reaction? No. For redox reaction there should be change in oxidation number. Next, here calculate the n factor. आइए भाई देखते हैं n factor. You have seen the rules. Now I will be directly using. How to use it? Now iodine is going to be 0. Here iodate. IO3 minus. So here iodine is going to be plus 5. How much is the change? Change is 1 iodine has how much change? 0 to 5. So n factor will be 5 multiplied by how many of the iodine atoms are there? 2. 5 2s are 10. Not a big deal. N factor is how much? 10. Next, iodate to iodine. What about that? Here it is per iodate. Sorry, not iodate. Per iodate to iodine. Here it is plus 7 converting into 0. How much of the iodine is there? Of course, you can see that n factor equals to change is 7 into 1, that is 7. FeO, that is how much? Plus 2 converting into plus 3. So for FeO, the change will be how much? Change 2 to 3 is how much? 1. How many of the iron is there? 1 ones are 1. But what about Fe2O3? What is the n factor? I can see that the 3 to 2. How much is the change? 1 ka change hai multiplied by how many of the irons are there? 2. So it will be 2. So please do not understand ki every time n factor for both of the substance will be same. No. Please take care about that. FeC2O4 converting into Fe plus 3 and CO2. In all these examples, we have seen that only one atom was changing its oxidation number. Yes or no? But here what is happening? There are two atoms in the same molecule changing its oxidation state. And always remember, if both of them are oxidizing or both of them are getting reduced, in such cases what happens? You have to add the n factors. What I'm saying, if both of the atoms are getting either oxidized or getting reduced, just add the n factors. Here what is that? Fe is plus 2, carbon is plus 3, converting into plus 3, carbon is here plus 4. So iron is converting from plus 3 to plus 2 to plus 3, so therefore N factor 1 is how much? 1. What about this carbon? Carbon from +3 to +4. How much is the change? 1. How many of the carbon is there? 2. 1 2 is 2. So what is the N factor 2? It is the N factor 2. So what we can say? The final N factor will be equals to N factor 1 plus N factor 2. It will be equal to 1 plus 2, that is 3. I hope you understand it, how it is coming, right? Now N2H4 converting into HNO2. What is this? N2H4. Hydrogen will be having +4. Nitrogen will be having, I hope you understand it, -4. But how many nitrogen? 2. So one nitrogen will have -2. Will have -2 oxidation state. Converting into HNO2. Nitrogen here is how much? +3. So -2 to +3, how much is the change? 5 is the change. What is the change? N factor change is 5. -2 to +3. अरे 2 to 3 का मतलब 1 तो मत कर लेना. -2 to 3, -2, -1, 0, +1, +2, +3. Changes 5. Multiplied by how many of the nitrogen is there? 2. 5 10 to the 10. So N factor comes out to be 10. Very easy, right? Next, V2O5, V2O3 converting into V2O5. Here it is +3. Here it is +5. Change is how much? I hope you can see that. N factor change is how much? 2. And how many of there is there? Vanadium is there? 2. 2 to the 4. I hope it's very easy for you. You can do that. Next, equivalent weight. What is equivalent weight? Equivalent weight is nothing but molecular mass divided by N factor. लो भाई ये तो कभी का हो गया. इसमें कौन सी बड़ी बात है कि नहीं? Next आ जाओ. Law of equivalence. What is the law of equivalence? Law of equivalence says that if there is any reaction going on, so gram equivalence of all the substances in the reaction is always same. What is gram equivalence? Gram equivalence के कुछ formulae होते हैं. You have to keep in mind always. According to this law, the number of gram equivalents of each reactant and product in the reaction are equal. ठीक है? अब gram equivalents के कुछ formulae होते हैं. Though I have not got that much of time that I dig deep into it because it's a very beautiful, very interesting topic. But still, okay. But still, you can just do that few things. Number of moles into N factor. N factor is nothing but we have seen that how to find out N factor right now. Yes or no? Next, it can also be written as, because we know that number of moles can be written as molarity into volume in liter. So what we can say? MV in liter into N factor. We all know that molarity into N factor. Molarity into N factor is also known as, अरे हाँ भाई भाई, normality. What we say? Normality. So normality into volume is liter is also known as, it is also known as gram equivalents. What about one more thing? Because we know that mass में convert कर दो. How to convert it into mass? We can convert it into mass like this. Given mass divided by equivalent mass multiplied by volume in liter. If it is volume in liter, what will happen? Multiplied with volume in liter. Volume in liter cancel. So what we can say? Given mass by equivalent mass. These are the formulae for gram equivalents. Always remember. But if you have to convert into milliequivalents में n को क्या कर देना? If it is milliequivalents, it will become millimoles. Rather than moles, it will become millimoles into N factor. या फिर इसी को क्या बोल सकते हो? Molarity into volume, but not in liter, but it will become milliliter into N factor. You can also say it normality into volume in milliliter. You can also say it W, that is mass by E. E is what? Equivalent mass, but this will be in milligrams, not in grams. So always keep in mind these things. You have to take care about that. Okay, so please keep in mind and always remember 1 gram equivalent equals to, or let's say some milliequivalents are given. Let's say some milliequivalents are there. So 1 gram equivalent equals to 1000 milliequivalents. That's that thing you have to keep in mind. Next, calculate the number of moles KMnO4 that will be needed to react completely with 1 mole of ferrous oxalate in the acidic solution. First of all, you have to understand that how the reaction takes place. KMnO4 when reacts with completely with ferrous oxalate, FeC2O4 converts into, this Fe is here +2, carbon is here +3, because it is a very strong oxidizing agent, and in the acidic medium, yes or no? So if H plus is there, I hope you all know that. Here manganese converts from +7 to +2. I hope you all know that. So here Fe first of all converts into Fe +3, and carbon here converts into carbon +4, that is from carbon dioxide here. And what about this manganese? Manganese converts into Mn +2. Just see that. What about these things? Can you see? Fe from +2 to +3 oxidation, +3 to +4 oxidation. Whenever I told you the two things in one same substance is getting oxidized or getting reduced, the N factor always yes gets added. So how much is this N factor? 1 is how much? N factor 1 is how much? 1. And n factor 2 is how much? N factor 2 is how much? 2. So total n factor is how much? N factor for FeC2O4 is how much? Ferrous oxalate is how much? 2 plus 1 is 3. What about this KMnO4 in acidic medium? I hope we all already know that n factor is how much? For this the n factor will be 5. Now we know that for any reaction, what happens? Whatever the two substances are reacting, their gram equivalents are same. If n factor is there, where the n factor was there in this whole formula? Arey, I have seen that. N into n factor. Yes or no? It is asking for what? Number of moles. Acha, number of moles of KMnO4. Chalo आओ देखो. N into n of KMnO4 multiplied by n factor of KMnO4. N factor of KMnO4 is how much? 5 equals to moles of ferrous oxalate. Moles of ferrous oxalate is how much given? 1 multiplied by what is the n factor of oxalate? 3. So n will be equals to 3 by 5. Array 3 by 5 is how much? 0.5, 0.6. So what is the answer? 0.6. Not a big deal. Easy to do it. Calculate the volume of 1 normal H3PO4 required to react with 20 molar 2 normal calcium hydroxide solutions. First of all, you have to understand it. What is the n factor for calcium hydroxide? It is n factor having 2, because how many of the OH it can give? 2. H3PO4 how much? Because you can see that n factor is how much? 3. Because how many of the H it can give? 3. Phosphoric acid. Because to react with 20. So I hope you understand it. With the help of volume and normality, you can find out milliequivalents. Yes or no? Right. Okay. So milliequivalents of calcium hydroxide, because it is base, right? Base and acid will also react in the same way only, right? And law of equivalence kahin bhi waste nahi hoga. It will always be same as it is. So gram equivalents of H3PO4. Not to think more. Here calcium hydroxide is how much? 20 into 2 will be equal to what it is asking for? 1 normal. Normality is how much? 1 into volume in milliliter. Let's find out how to do that. So volume of H3PO4 will be how much? Of course you understand it. 40. So answer will be what? 40 milliliter. Not a big deal यार, ये तो बहुत easy हो गया ना. Next. Now electrochemical series. Always remember electrochemical series कहाँ पे पढ़ने का है? Of course we have to study in electrochemistry also, because we are going to cover that chapter also here. So we'll study it there also. So abhi I will be just telling you things very, just through the question solving, right? If you can understand it, I hope you understand it. Here we are only going to talk about the SRP, that is standard reduction potential. Always remember, if SRP is high, means something tries to be reduced. If something tries to be reduced, means it is acting as the oxidizing agent. Always remember, if something has high SRP, it will be acting as the oxidizing agent. Next, if something has lower SRP, let's say SRP negative, so it does not have the tendency to get reduced. If something does not have the tendency to get reduced, means it is acting as the oxidizing agent. Means it will have the tendency to get oxidized. So and it will act as the reducing agent. So if something has lower SRP, it acts as the reducing agent. Always remember these points. Nothing more than that. I would like to just tell you these things. चलो कुछ चीजें मैं बता रहा हूँ, जैसे याद रखना. Always here to here SRP decreases. SRP increases as we go top to down. Okay, top to bottom. So I am starting with lithium. Always remember one thing. ऐसे कुछ याद करेंगे, जिंगल मैं बता सकता हूँ. लेकर बारात सारे कल नाचे. That is what? Lithium, potassium, barium, strontium, calcium, sodium. लेकर बारात सारे कल नाचे. Mg, Al, Mn, Zn, Cr, Fe, Cd, Co, Ni, Sn, Pb, hydrogen. I hope you understand it. तो yes, इसके आगे क्या? Just cut here and then Mele, Mg, Al, Mele, May, John, Karina. John, Karina, I hope you know that they are actor actresses. FeCD. Now cut. FeCD, CO, Ni, Sn, PbH. So fake CD को. CD I hope you understand. Kind of compact disc, right? Fake CD को निशाने पे है सुई. If you just throw it for to just spit it in one needle, सुई. निशाने पे है सुई, सुई CY, you understand it just for the jingle purpose, right? Now you have to understand Br, Cl, F, Ag and Au. If you do not remember, not a big deal, you can just remember this Br, because after iodine, bromine, chlorine, chlorine. So here as we go downside, the SRP is increasing, so highest SRP is SRP here is maximum, and here SRP is minimum. If SRP minimum means strongest reducing agent, and what about this? This is strongest oxidizing agent. If something is strongest, chalo theek hai, directly come to the question. Better strength of oxidizing and reducing agent from the rules, we can see that you can do that. Predict whether the metal can liberate hydrogen from the acid or not. If something is above hydrogen, so all these metals can remove hydrogen from acid. Next, the standard electrode potential E0 value of this are given, these values. Okay, the correct decreasing order of the reducing power. Always remember, whichever metal is above top of the series, that will be stronger reducing agent. Always remember. So higher positioned metals are having low SRP and they are stronger reducing agent. If you remember the whole series also, na, that series also, na, from there also you can do it, but still the values are given. So if the negative values are high, means they are at the higher state, means they are positioned higher. So I hope you can see that minimum value. Where it is the minimum value? Here it is, minus 2.93. It is for what? Aluminium AgK. It is the third value. Means potassium is positioned at the top. So potassium will be the strongest reducing agent. After that, what is less than that? Minus 1.66. It is the second value. No, first value, sorry. So first value is for aluminium. So what will be there? Potassium will be more than aluminium. Then less than minus 1.6 is what? Minus 0.7. Minus 0.7 is for some third value. Sorry, it is fourth value. Fourth value is for chromium. So then comes chromium. And then the maximum value is what? Plus 0.8. It is for what? It is for Ag. So after chromium, what will happen? Ag will come, right? So potassium is more than aluminium, chromium, Ag. I hope it is very easy to do it. Next, standard reaction potential of the half reaction are given below. Now, the strongest oxidizing and reducing agent. Always remember, strongest oxidizing agent means we have to think about the highest SRP. And you have to think about, whenever you are talking about the reducing agent, strongest, then you have to think about it, lowest SRP. Chalo, talk about it. Where the lowest SRP and highest SRP. Here it is the highest SRP. Where is the lowest value? Here it is the lowest SRP. Lowest SRP is for reducing agent. ठीक है? आओ जरा देखो. What is reducing agent? Something gets oxidized. So here, can you see that iodine is getting reduced? So it cannot act as the reducing agent. It is oxidizing agent. So this one will be conjugate, will be reducing agent. Yes or no? So I minus, because for lowest SRP is for strongest reducing agent. So I minus comes as the strongest reducing agent. What about oxidizing agent? Strongest oxidizing agent connected to highest SRP. Where is the highest SRP? Here. Now think about it, which is, first of all, you have to understand which is oxidizing agent. Something that gets reduced. Kya? It is going from minus 0 to minus 1. Of course, it is oxidizing agent. So therefore, it will be strongest oxidizing agent. Always remember. And this will be weakest reducing agent. And whereas this will be weakest oxidizing agent. And while here it will be strongest reducing agent. So what we have got, strongest reducing agent is I minus, and strongest oxidizing agent is F2. So that was all from my side, class. Though in electrochemical series there is a lot more things to say, to tell you, but still no problem. We will complete it, whatever the left part is there in electrochemistry. But yeah, we all have to understand it. It's a revision class. We have to try to complete all the important types of reaction. We have solved more than 50 types of question today. So please go through this whatever the video is there. It will very much helpful. I'm very much you can say hopeful about that. Please go with that. Study these in this series. Please do not leave any video, because in every video we are solving many different and important types of questions. So that will be only thing that I would like to say. Keep on preparing, be in the full josh and take care of your health, take care of you. Thank you. Signing off.